I'm Gabriel, and the idea of this talk is just to play around with Akka Streams and create a very simple flow and that we can use to play around with data analysis. It's not really complicated, more like a toy example. But the interesting thing is how I want to show how easy it is with just using a streaming solution. We can do interesting analytics with real-time data. We don't really need to use a big cluster. Just even with a relatively simple machine, we can extract interesting data. And so we don't really need to spend a lot of resources. The thing that attracted me to streams is like an easy way to start thinking about functional programming, because it basically is a data flow and data transformation. By using streams, actually, we get many things kind of already solved for us. The main components of the stream we are going to use are sources of data that can read from files, that can connect to different type of queues. The most popular, in previous project we use, there's a Kafka data source for Akka Streams that you can use to get data. The other side of the stream is the sink. When the data comes out of the stream, you can write it on. Again, we can write it into a Kafka topic. We can write it into the terminal. We can write it into a file. For playing around, we can write it into the terminal. And then there is a transformation that happens between the source and the sink. And that's where the interesting part happens. When we get the data, we filter out, we enrich them, we can split into different streams, we can accumulate values. That's kind of a very quick overview of what happened with the streams. Most of streaming solutions I know for Scala, Akka Stream, FS2, Monix streams are pretty similar in high-level concepts. Each one has a different flavors. Actually, I'm most familiar with Akka Streams. I use it in different projects, and it's very easy to come up with something that it can be really useful with just a couple of transformation steps. So the idea today is to just play around. I need to increase this. I have everything prepared to write a simple stream. We're going to create a simple flow. This is based on a previous project. This is inspired into a simple flow of, we have customers that requires our products. So we have an income source of request that basically the request is the customer ID, the product SKU, and the quantity they require. So I have, in this case, I have a random a generator. We are not reading from Kafka or anything. We just have basically an iterator that generates random elements. So the first thing we can do with the stream is let's write it. Let's write it into the console. Oops. So this is the whole stream running. Let me see if I can increase that. This doesn't say as much. It's just code. So let's try to get more information. Here I have my storage. In this case, is FalsoDB. We store everything in this fake database. Here we have the customer information and the product information. And like every database, we have a find for customer and product, but returns a future. So if I want to use here, I will want to do map. The input is the tuple with the values. So we do FalsoDB, find the customer information. You see here the customer information is, actually this is customer, is the first element of the tuple. But if I run this, actually I'm going to get something that doesn't make sense because this returns a future. I can internally wait for the future, but it won't help. Is you're looking so. Akka Streams offer me wait for asynchronous, and I give you the parallelism. So this automatically will take care of assembling, running the futures while running the stream, and get the right results out from the future. That's a little better. We'll just get the customer information, but actually we are losing the data from the original tuple, so we're going to put that back on the triplet. So we're going to, this is the customer, and we're going to copy the original triplet, but replacing the one with the customer. And in the second place, we have the product information. So let's do the same. Let's find the product. The product is in place too. This is, let me put a better name here. That's okay. So if I run it, this looks a little better. I have the customer, the product they're asking, and the quantity. But also now we want to do something a little more interesting. I have a service that gives me the market price for the product they're asking. Here I create a small service request. This uses Akka HTTP. Akka HTTP it can be used directly as a stream in Akka Streaming. So basically, it's a flow from a request and the original value, and returns, and the output of that flow is the response with the original value, so we can match. This is that flow. Use cache connection pool. Akka Streams automatically takes care of pooling the connections, handling the responses, balancing the request, having request waiting, because obviously this is a streaming solution. If the server on the other side takes more time or response, it sends a back pressure, so the initial collection stops sending data. So it slows down, and so we can continue the flow without breaking everything or manually handling the streaming. Basically, what I do in the flow is just create my request from the original data, and this one manages the response, transform the response into this one creates the whole flow. This is how we get the URL. I'm having a function to create the URL because it depends on where I'm going. So create a request here, connect to the flow, and manage the response. That's another flow. It creates one whole flow that I'm going to reuse here. And the input will be the customer, the product, and the amount of products I want to get. And I'm going to output a big decimal. That's the market price of the product. Basically, what I do is I take the product, the input is a tuple, I get the product, I get the SKU of the product. That will do the service call. I'm going to show this is the service. It's a very simple service using, again, Akka HTTP in this case. Basically listens to market price, and in the URL it takes the SKU of the product and returns the value, the price on the market. If you see the products we have, spice, sun-dried meat, and ice cubes. Spice is very expensive. Ice cubes in that desert planet are somehow expensive, but sun-dried meat is pretty cheap. So I'm going to run that service. That just will put up the web service with the market data. And we're going to run our flow. That now at this point, I need to get the market price. And somehow. Okay. Somehow something got mixed up. Where is the mix-up? Oh yeah. At some point, I mix up this. I put the product data in the wrong place, and now we work. You see, but we are kind of printing, but the whole response, we are not doing anything with the response, so let's do something with the response. The response is response, and also the triplet with the customer, the product, and the quantity. A response, in the response is an HTTP response, so I can, if I have a response, I can use, again, Akka HTTP to marshal that into a string. And then, actually, this is my problem here, that this is a feature. So again, we're actually going to use map async with some parallelization factor. And this will give me the price as a string. And actually, we're going to create an object that have the fulfill object that basically combines everything: the customer, the product, and the quantity. Customer, product, quantity, and the price. Actually, it's a big decimal. So here we have the whole fulfill orders. And actually, one thing we can do is to write this into a file. But I want to show first one thing, because I'm kind of running out of time, right? There's something I actually ran out of time for showing this, but one thing is the other approach to Akka Streams is to create graphs. So I have the same flow that before, but then I can insert a broadcast that splits, fan out the stream, repeats the same data to different outputs, and then I can hook up different aggregations while it's running. In this particular case, if you see this one, it will generate a new substream in this case it's every 30 seconds, and it will accumulate in that stream the total and aggregated by the aggregated total by product. That's again running using my web service to ask for the customer price. This is one of the splits that takes is using group within. Basically, it gives you every n numbers of seconds on or until you fill the collection. It gives you a Scala list that then you can analyze with normal. In this case, I'm doing a fold to get the total and the average. But this is slightly different because this actually generates a substream, and you are not limited. You are not generating the collection in memory. Just the substring. This is both things running. These two total and average is calculated by using the Scala collection, and this one is the substreams that says, okay, the total produced by this date is this, and by customer is the total required by customer. And I think I'm out of time, so if you have questions or things. The idea is to just something very simple to use to play around and create even something that it can be real. I did a couple of data analytics pipelines for different customers, and it's not really that far from this. And you can run it in like one big box. You don't need a whole cluster. Using probably if you want to scale, you can use Kafka. You can split with Kafka. But then, yeah, you can do a lot of analytics in a model really simple. Akka Streams will take care of the back pressure. There's a couple of ways to handle errors in the stream, restarting, or you can create a flow that counts how many times you ask for the service, add like exponential backoff to the request. There's a lot of things that can be done, and it's relatively very accessible. Thank you.